I knew I wanted to study the ocean and the things in it from a young age. I was mesmerized by the world beneath the waves. Throughout my career, I've learned a lot about the challenges that animals face in the ocean today, but I didn't want to come here and tell you the doom and gloom stories. Dr. Nancy Knowlton, a co-founder of the MAS program, once said, "The best way to encourage conservation is to share our success stories, not to write obituaries for the planet." My capstone project has given me a chance to tell you today about a few of the success stories and some of the amazing science that is helping guide conservation efforts and the designation of critical habitat. This is Naya. She is an East Pacific green sea turtle. She has an amazing story. A story about resilience, a story about science and conservation, and a story about hope. Sea turtles have been present in human cultural traditions and mythology for millennia. Many cultures have revered these charismatic animals as celestial beings with supernatural powers. Despite our close connection with these animals, overharvesting, habitat loss, disease, pollution, and fishing have greatly reduced the numbers of sea turtles over the past few centuries. Conservation efforts, especially those at nesting beaches, along with the campaigns against the harvest and trade of turtle products, have helped some of the populations of green turtles gradually recover. Today, East Pacific green turtles can be found in many of the bays, lagoons, and coastal inlets in Southern California, even right here in La Jolla. Green turtles, like Naya, inhabit tropical and subtropical oceans around the globe. Upwelling along coastal areas, like we have here in San Diego, creates highly protective waters that are used as foraging hotspots. East Pacific green turtles, a population commonly found from Southern California to central Mexico, are currently listed as threatened under the Endangered Species Act. Recent assessments show the numbers are increasing, and this is really great news, but more work is needed to ensure the continued success of these animals. Much is still unknown about these long-lived ocean travelers. They require air to breathe and land to lay their eggs, but the majority of their lives are spent underwater, which may be the reason that a lot of people in San Diego know that there aren't neighbors of sea turtles living under the water. For one component of my capstone, I compiled lab and field-generated data, maps, and videos within an ArcGIS story map to tell a story about a few of the well-studied green turtles living underwater in San Diego. Today, I will be talking about 3 of the turtles in my story map, Naya, Donna, and Peter. Data collected from each of them over the past several decades has helped paint a more complete picture of the life of a green turtle and will further improve management and conservation efforts in the future. Green turtles have a brown, olive, or gray-colored shell called a carapace and a lighter yellow to white underside called a plastron. Their name actually comes from the color of their fat and is a result of their diet. Green turtles have a complex life history. After hatching, their life begins with a juvenile oceanic stage where they eat jellies, squid, and small fish. As they age, green turtles exhibit a habitat shift and settle into coastal areas where they begin to eat mostly seagrass and algae. Here's a green turtle eating some red algae off the coast here in La Jolla. Knowledge of basic life history, including habitat, reproduction, lifespan, and growth rates, is critical for effective conservation. However, long migration distances between feeding grounds and nesting beaches makes these animals very hard to study. Mark and recapture studies, satellite telemetry, genetic tagging studies, and aerial surveys are extremely valuable. But how do we learn more to ensure the continued success of these animals? The past few months, I have been helping members of the Marine Turtle Ecology and Assessment Program at the NOAA Southwest Fisheries Science Center take inventory of the East Pacific population of green turtles in San Diego Bay. Each year, since 1990, green turtles are carefully captured with a net and brought onto land for a complete physical examination. Each turtle is weighed and measured, and notes are made about body condition. Skin and blood samples are taken from new turtles to determine hormones and genetics. A digital microchip, along with a flipper tag, is attached for easy re-identification. These yearly captures have created an important long-term data set, building a better understanding of the movement, use, and habitat patterns of these turtles. It's important to mention that it is always unfortunate when a sea turtle dies, but by using samples collected from dead turtles, we can learn a lot to help us protect and conserve those turtles still living. When a turtle dies and is found stranded on a beach, members of the NOAA Stranding Network, including myself, are first responders. A necropsy is performed to find out more about what happened, and during the necropsy, the humerus bone, found in the front flipper, is removed for later analysis. Skeletrochronology, the study of growth layers in bones, is also a tool that recently expanded our knowledge about sea turtles. Like rings on a tree, sequential layers of bone are deposited over a turtle's lifetime. Using a cross-section of that bone, it is possible to estimate age and growth post-mortem and to create a picture of habitat movements back in time. Along with fieldwork, I have been working with NOAA's Marine Turtle Demography Laboratory, preparing samples for analysis. Stable isotope analysis has shown that the values of nitrogen and carbon isotopes within these annual growth layers reflect specific ocean regions and prey. This skeleto-iso data makes it possible to detect the timing and transitions between oceanic and coastal life stages in turtles. So let's dive further into Naya's story. Naya was first encountered as a large adult in San Diego in 2003 with a body size of 108 centimeters. She was captured 6 times over 13 years and provided researchers with a wealth of information before she died. Using skeleto-iso analysis, researchers were able to estimate growth, body size, and growth rates for each year by identifying and measuring rings in the bone. Naya's plateau in growth rate, seen here in the bottom graph, suggests she had reached maturity, shifting resource allocation from growth to reproduction. East Pacific green turtles like Naya have likely been living in San Diego Bay for centuries. Today, most of the turtles reside in the shallow waters near the location of an old power plant. Constructed in 1965, the power plant outflow warmed the ocean water several degrees above normal. The warm water, along with the abundance of eelgrass, made this area prime habitat for these turtles. The power plant closed in 2010, but the turtles are still in the area and actually increasing in numbers. Today, San Diego Bay is one of the northernmost major feeding grounds for green turtles in the eastern Pacific. The map on the right shows Naya's capture locations. She was consistently found in the south part of the bay near the power plant. Early captures found her near the outflow, where the water was the warmest, at the Green Star, and later captures, after the plant had closed, found her near the old inflow. Naya's isotope values suggest a change in habitat and/or diet between 2000 and 2001, as the isotopes increased and remained high. Coastal lagoon foraging, like we have in San Diego Bay, results in higher nitrogen values than open ocean foraging. Unfortunately, Naya was found stranded in 2016, but by analyzing her bones, researchers were still able to learn a lot about her life. San Diego Bay is an urban waterway utilized by industrial, military, and recreational activities. But it is also home to over 60 green turtles, with new individuals continuously recruiting to the area. Understanding how and when green turtles use these urbanized feeding grounds is of critical importance when determining critical habitat and management. Donna is another turtle that has helped us understand the movements of East Pacific green turtles. In 1990, Donna was one of the first turtles captured by Dr. Peter Dunton, and he sweetly named her after his wife, who is pictured here assisting with captures. This turtle became well known to researchers after being captured 9 times over 24 years. At first capture, she weighed 176 pounds. 12 years later, she'd grown to a whopping 330 pounds, almost 13 pounds a year. Her growth slowed in 2003, suggesting she had reached maturity. Skeleto-iso analysis showed that she was a long-term forager here in San Diego Bay. And from this data, it might appear that Donna never left San Diego, but there's more to her story. Green turtles migrate to nest at the same beach that they were born at in a process called natal homing. In 2002, Donna was fitted with a satellite tag that tracked her movements for a year. Donna's the red line seen here. She departed the feeding grounds in San Diego, Point A, and migrated directly towards the nesting grounds in Revillagigedo Archipelago, just off the southwestern coast of Mexico, Point B. She took almost 90 days to reach the island, almost 1,000 miles south. She stayed for 230 days, likely nesting several times before making it back to San Diego in only 48 days. Genetic analysis recently matched the green turtles in San Diego to their nesting beaches and revealed that the group is mostly comprised of turtles from several different nesting populations in Mexico. This information will enhance the long-term conservation strategies for the species. Peter, named after the researcher that first captured him in 1990, was encountered as a juvenile weighing only 64 pounds. 12 years later, he was 286 pounds, growing 18 pounds a year. His growth slowed over time, and in 2018, the capture notes indicated he had a soft plastron, suggesting he had become a reproductive male. Peter was recently fitted with a detachable camera to monitor his activity for 24 hours. Here is a recording from that camera showing Peter eating eelgrass in San Diego Bay. Peter was recaptured in South Bay just a few weeks ago, 33 years after his first capture. He is currently the longest studied green turtle in San Diego Bay, and the researchers that caught him the first time in 1990 returned to see his progress, and they're pictured here on the right. Hopefully, this large male turtle will continue to flourish and contribute even more to the current knowledge about green turtles. The long-term data stored in the bones of sea turtles, along with the information gained from multiple captures over time, has helped reconstruct movement patterns of these highly migratory animals. New coastal development in the southern region of San Diego Bay is a growing concern for this population, as it will likely bring increased boat traffic, fishing, and pollution. There's a growing need to find science-based solutions to these problems. It will take the involvement of the whole community to implement them, which is why it's important to me to share the success story, to give people hope, to inspire action, and to ensure the protection and continued success of these turtles and their habitat. I hope you will take the time to take a look at my Turtle Tales story map online, to learn about more East Pacific sea turtles that live underwater in our backyard, and to find out what else you can do to help. I hope the turtle stories bring curiosity and a better understanding of the amazing science that is improving conservation efforts for these sea turtles around the globe. I would like to give a special thank you to my capstone chair, Dr. Callie Turner-Tomasevich, and to the rest of my committee members, as well as the members of NOAA's Marine Turtle Ecology and Assessment Program. Without these people, their time and resources, this story could not have been written. Thank you very much to my classmates and my family and friends. Thank you. I definitely learned a lot about the need for international cooperation. And I think bringing the idea that these animals are here. I lived in San Diego for a very long time before not knowing that there were sea turtles here. And people can't protect what they don't know. And so that was part of my motivation, and that and the really cool science.
Thanks, Dominique. And for those on the live stream that didn't catch that, the question was, can Dominique share this story with the mayor and the world through a variety of channels? And the answer was yes.
Sweet. Yes.
I've got a question. Why turtles?
Why turtles? Some of the conservation projects I've been a part of didn't give me a lot of positivity, a lot of action. It was a lot of doom and gloom. I think it's imperative for people to learn about the things that are around them to want to protect them. And I think sometimes some of the science that goes into the designation of critical habitat, which is around the corner and is coming hopefully this year, it's really important to see the cool science that goes into it, the long-term data set, how hard these highly migratory animals are to study. And the chemistry behind it is really fascinating. So it gave me a chance to try and bring that to a broader audience.
A question right
I have a home in Florida, and we come from Florida. There's been a lot of lives here, both on the Gulf Coast and the Atlantic Coast. There's very active conservation groups, turtle monitoring groups, nesting sites protected and that sort of thing. Is that true on the west coast of California and further up the coast?
It is. And we're actually getting more citizen science. We're getting more people involved about sightings. If you saw Mel's talk earlier about really it takes the community to say where you've seen them and actually really bring value to the fact that there's so much to be learned from these bones now. So the chemical analysis of these bones is just as important as studying them when they're alive. And I think that's a really cool take home.